Okay, welcome back to CS-289. Looks like this week we'll be starting up our web servers and getting our first content deployed. So let's get into it. The things that we'll be talking about will be platform configuration for both IIS and for Apache. We'll look at the website content. We'll cover again the default documents, look at MIME types, and how to configure multiple websites to each of our servers and the different methods that we have to do that. So this week we'll start off with IIS, and let's take a look. The IIS MMC is definitely going to be the way that we're going to configure IIS. This is the GUI configuration utility. Remember that you can also use app command or PowerShell. The vast majority of our configuration will be done through IIS MMC. It's just going to be the simplest for the vast majority of us that we are used to using the GUI, and that we can adapt to using PowerShell or the command line, but I think that we're just most used to using the GUI whenever possible. At least when we're learning this stuff, right? Later on, we can transition to, as soon as we know what features we want to get to, we can get to the different features using the alternate methods of configuration. The thing with IIS is that you have features and properties at the different levels. In the last presentation, I alluded to this a little bit. We'll take a more closer look at this in the next couple of slides or so. Remember that anything in the lower nested settings are inherited from the higher level settings, but that each one of the lower level settings or objects can always override. You can deny the inheritance and override what the defaults were at the higher level. In general, in the IIS GUI, you're going to click on a feature to see what its tasks and actions are available, or what actions are available for that particular object or action. Double click to view its form or properties view. Most of the time it'll be a checkbox or a radio box that says on or off. If there are specific settings that need to be typed in, the form will pop up and prompt you for those types of materials there as well. And you can select a particular property to view the tasks or the actions that are associated with that particular property. So in IIS, you'll see on the left-hand side, you'll have the hierarchy of how the features and properties work in IIS Manager. You typically have your server name features, whatever you've named your particular server, many settings available there that are inherited by all of the sites on that particular server. Each of the sites are available there as well. Remember, it inherits some settings from the server name options. You can add your own defaults for each of the particular sites. I think this talks more specifically about websites versus FTP sites, which we'll learn about later on. So these are the settings or defaults for the websites that we're looking at. You can have multiple sites on one server, so you'll often have a site name or properties for one particular site name, and then inside that particular website, the directories and the files that are in that website can have their own properties there as well. And on this next slide, the hierarchy I'm referring to is really on this left-hand side there. that here is our server properties. We'll have all of our sites that are inside of this server, and then an individual website that's on this server, and another site that also exists on this particular server. On the right hand side are all the features and the options. You'll click or double click on these particular features to get to the settings for those particular tasks and settings for whatever object you have selected on the left hand side. So that's what we're looking at in IIS. It's standard-ish Windows configuration, just that we're probably more used to using the GUI than anything else. On Apache, it's a little bit different. In general, there's no GUI for it. That everything is configured with just a plain text file. That if we installed Apache to its default state, aka we installed from source like we did last week, and we did not install from package because OS packages would probably put these files in different locations. As long as we installed via the Apache defaults, the configuration file that controls all of Apache should be located in this particular directory here. User local apache 2 conf httpd.conf, right? And with the proper Apache CTL command, we can actually make Apache start up with a different httpd.conf file or whatever configuration file you want to name it and wherever you want to put it. But by default, without the specific options, everything will load from this particular file here. If you open this particular file using Nano or VI, or if you have a GUI installed, open it with a text editor, probably with administrative permissions, root permissions, or sudo permissions, you'll see that there is a lot of content in the default file. It is all relatively well self-documented, meaning there's a lot of helpful text and comments that appears in the file along with the specific configuration directives that are used on the default file. If you open up that file, the comments are typically prefixed with a hash sign or the pound sign, or they call them hashtags now, but that's not what the actual character is. I think it's something like an octothorpe. Someone told me that at some point. Anyway, the hash symbols indicate comments. These comments are not going to be read by Apache as a configuration statement. It will just mainly sit in the text file for the humans to look at and interpret in order to give some context and instruction to what the rest of the configuration commands are in this particular file. There is extensive documentation in the default documentation. It makes the file rather large. It is possible to remove a lot of the commenting and some of the unnecessary configurations without affecting the configuration so much. Keep in mind that however large the default configuration file is, not all Apache directives are represented in that file, and it is likely as we go through the term you'll have to add your own in as we start customizing our Apache configurations. So the configuration statements in httpd.conf are typically a name followed by one or more parameters. Directory index, for example, gives the name of the file for it's the default document. It's what files should be looked for when a generic or a general URL is requested. Another one would be the error document. Notice that there are two parameters there. There's the error document command or configuration statement, or the directive as we call it, followed by 404. Notice the spacing, that this means this is one particular configuration that we're looking at. And then default basically in this case says use the default 404 statement for Apache's configuration. Some minimum set of configurations that are required for Apache to even run include the idea of the server root, the document root. Server root is essentially where the Apache binaries and supporting files are located. The document root is where the default website documents are stored. You need the name of the server, which should be the reverse DNS name of your particular server. It doesn't matter that much. We can get by without putting it in there or with making something up. But in general, the server name should be the domain name of your server, and that if you typed in your server name into a regular web browser, it would take you to your normal server. The directory index, again, is your default document. This can be appended, so you can say index.html, comma, no space, index.htm, comma, etc., etc. The user and group directives there tell Apache which user and which group to run its own binaries as. This will make more sense, or will mean more when we start playing around with processes and permissions for accessing the document root content later on. Error log is essentially where to store errors or typically alerts that would pop up while running the Apache web server. So if your web server did not behave appropriately or crashed or stopped running, you could check that particular directory for a description, or at least more information on what errors Apache is running into when it gets to crashing or not running itself. The directory directive inside of the greater than, less than sign gives some defaults for the website located at var web. If you'll notice, this directory is the same as this directory here. We will play around a lot more with the directory setting here, basically saying that when Apache serves a file from its file system under this location in the file system, these are the options that we want to include. Typically, indexes is do you want to show a listing of the files? So typically we say none there, because that's normally a security risk. That when someone requests a general or a generic URL, you want to look for the directory index file, one of these index.html or index.htm, and return that to them. And if those aren't found, I would rather give back a 404 not found error rather than listing out, oh, well, I didn't find that particular file, so here's a list of all the files that are available in that directory. You go ahead and choose, which is typically a security issue than anything else. So, more explanation into the directory directive. This is actually more called a container. And this container really gives specific options for the website or the directory that's located, or the file that's located or specified by that particular directive. If you remember, in IIS, we had our hierarchy of server name to servers to a particular website, and each lower item can override the defaults that are set by the higher item. This is what the container typically does for Apache. That if we specify certain configurations for certain directories or files, those options for those directories, even if they're contained in a default document or a default website, these container directives would override anything that was set for a container above them. So this is pretty much the same inheritance issue coming along, that we're specifying specific directives or specific options for a directory or file specified by that particular container. The HTTPD conf file is typically large, but typically it's only that we make changes to a small portion of it that will change one particular setting and then reload the Apache system so that it runs with the new commands. If you make a change to that file and there's an error in how the directives were handled, meaning you gave perhaps too many options for a particular directive, or you didn't give enough, or you gave a directive with an option that doesn't exist, Apache may refuse to run. So you might make your change and issue your Apache CTL start or restart, and you'll get an error message on the screen that says Apache died. Typically, it's going to be an issue with the configuration file. One of the ways to test the configuration file before you try running or restarting is to use the config test option for Apache CTL. So if you do Apache CTL config test, it will go through and parse the default httpd.conf file and see if there's a error that it can point out. And often it will come back and say, hey, error in line 53. However, don't get hung up specifically on whatever line number it says. Oftentimes it'll say it's an error on line 53, but that's because you left out something back on line 35. So certainly start off with the 53, and you may need to backtrack a little bit to see where you left out something. If you're used to programming, it's similar to leaving out a semicolon earlier on in your code and the compiler not throwing an error about it until 5 or 6 or 25 lines later on. So this gives you a hint, but it may not tell you exactly where that particular error is located. So once our web servers are up and running, we need content. We need to deploy the website, the HTML pages, and the images and PHP or CSS documentation that go with that particular site. Most of the time, the content that we will be serving will be called local content, meaning that for that server, the content that they are giving back to clients is located on a local disk that is part of that particular system. In IIS, you typically go to a particular site, one of the sites inside the sites directory, so a particular website. Go to its basic settings and check what the physical path setting is for that particular website. The physical path setting will often give a specific directory or specific path to where that website is loading its content from. Oftentimes it's going to be the C drive and the inet pub and web folder that is given as the root or the local directory where that particular website's content is located. In Apache, it's the document root directive. So as you go through the httpd.conf, look for the document root directive, and that tells you where that particular default website, or if it's part of a container, where that particular website's content is located on the local disk. And again, it will typically be a Unix formatted path, starting with the / for root and whatever directory path you have for where those particular files are located. All content is contained inside of a physical directory. That the website hierarchy duplicates the file hierarchy. So if you have a site named website 1 with a directory named images, then the URL that needs to access the images directory still follows the same path as the physical directory. So your HTTP would have to indicate, whatever you're going to with the images directory appended onto the URL to make sure that that points to the images directory in the file system so that you can find the particular image that you're looking for. So remember that the physical layout of how you store your files and your images will determine what your URL needs to be in order to access content. That the physical directory and the URLs will follow each other: directory, subdirectory, and file names. A couple of exceptions to this, but this is essentially how you want to organize your website on your particular servers. If there is a content or or images that are in paths that are not in the general document root, meaning they are on another drive or in a different directory in some other part of the file system, there are ways to force IIS and Apache to look in this other directory or look in this other location, but pretend to the client that they are all part of the same hierarchy. In Apache, you're going to use the options follow symlinks directive, and you should have, you should remember from the Linux classes that we can create symbolic links to other files and folders elsewhere in the file system. And those symbolic links would act as if they were the real files or directories in the location where you create the symbolic links. The options follow symlinks directive essentially tells Apache treat symbolic links as if they were real physical directories and files as far as responding to requests from web clients. In IIS, we have to use what are called virtual directories. Same type of thing, except they only point to directories. That virtual directories will only exist inside of the IIS manager. There's no indication inside the physical file system that these virtual directories exist. That they only show up inside of IIS manager, and you have to create them inside of IIS and give the directory to where that virtual directory is going to point to. So just remember, these virtual directories will not show up in Windows Explorer at all or File Explorer at all. They will only show up inside of IIS Manager in the hierarchy or content view of your particular site or website. There's other ways to look at content that is not on your physical server, and that's if you put information in a network share. The same issues will apply, that you can specify a particular website, source their content from information on a network server someplace. The file servers themselves or the web servers themselves will access that network share using their native clients, whatever's built in to the system, whether that is SMB or Samba or NFS. That the source or the mounted path will just be specified as the document root for that particular website. This is sort of not a typical configuration, but can be useful for perhaps specifying a common location on the network someplace for multiple people to add content to in like a business environment. So if you want to add your resume or you want to go in and change your particular profile, you can edit those files that would be stored on a network file server someplace. IIS can source Windows shares directly, that you can tell IIS authentication information for accessing that network share, or an option is to provide pass-through authentication, so that IIS would ask the client web browser, hey, this content is located on a network server someplace. You need to give me proper credentials so I can access that network server. And if the client, the user, types in credentials that are accepted, then IIS can give back that content. If the user types in information, username, password that is not accepted, then you'll typically get back your error, your 404 not found, or some other error that says, nope, you don't have access to that particular network share, so I can't give you that particular content. In last week, we talked a little bit about default documents. That, remember, when you request a generic URL, the default document is the list of files the web server should search for to return to the client in case of a generic URL request. In each of Apache and IIS, there's the directory index directive in Apache that lists the files in not alphabetical order, but the order that you want to search in. Be aware that Apache in Linux and Unix files are case sensitive. So if you put in capital index.htm, then Apache will look for a file matching capital index.htm. So make sure that you practice proper capitalization, and typically on Apache and Linux, Unix servers, the general case is to keep file names as all lowercase in order to avoid the whole capitalization issues. In IIS, you're looking for the default document feature, which exists at many levels, the server level, as well as the particular website level, as well as each of the individual directories underneath that particular website. Look for the default document feature, and it has the ability to show you a listing of what the default documents are, move them up and down, and add and remove a spelling or particular name of a default document for that particular server. Right? If default documents are not enabled, you will typically get one of two options will happen. You'll either get a 404 file not found error, because if the client is requesting a generic URL, if the default document feature is not enabled, well, then it doesn't know what file to give back to that particular client. So if it's not enabled, expect a 404 not found. If it is enabled, then you should get a list of you should get one of the documents in that list, preferentially in order on how that list is specified. If default documents are not enabled and you do have directory browsing, I mentioned this a little bit earlier, then when someone requests a generic URL and default documents are disabled, what the web server will do is return the listing of all the files and directories that are inside the generic URL that was requested. Now, this can be a security issue, so be careful with what types of files that you would put into that particular directory. You wouldn't want to, for example, put password files or code files in that directory. Oftentimes, this is used as a, hey, download my software directory, and all the software is just listed there. Make sure you don't have secure information or information that would be a security risk stored in a file or in a location that has indexes in Apache or directory browsing turned on for that particular directory. MIME types are a method of telling the web server and the web client what type of information is stored based on the extension of that particular file. For example, an HTML or a document ending in .htm and .html are typically just plain text. So the MIME type for .htm and for .html is usually just text, so that when a client requests a particular document that ends in .html or .htm, the web server knows to return the document or the contents of that document, the data inside that document, basically as plain text. And then it's up to the client's web browser to interpret that text as HTML code and show the right pieces in the right places. For some other files, there are other meanings there as well. Scripts are often .asp or .php or .cgi or even .aspx. If you have a program to run, oftentimes you'll have files ending in .dll and .exe. Side note, this is a big security risk. If you have a link to a .dll, you probably don't want to run it, but there are times when, for example, you're downloading software and you need a link directly to the installer, that if you're downloading a software installer, then Apache needs to know and IIS needs to know, send that information as binary, not text, as binary, so that it's an executable program by the time it arrives on the client's location. Other types of binary files include .zip, so that it's not returned just as text, it's returned as a actual binary zip file. Same thing for .doc and .xls. So MIME types are really just to tell the web server how to return the content of the document. And most of the time it's either going to be text or binary, or it's going to be a script of some kind that should run on the server and not actually be returned to the client. In Apache, the MIME types are given by the types_config directive, which typically points to a file named mime.types, which is under the server root directory in Linux or Apache. The IIS server has the MIME types feature that specifies just the same thing that we talked about, the extension with how that particular file should be sent over. It should be sent over as text or run as a script or sent over as binary. There is a default download type. I don't know if you guys remember, but the transition from Microsoft Word, for example, using the .doc extension to the .docx extension actually caused a big issue with our Moodle host at the time that they knew about .doc files, and that if you clicked on a .doc file inside of Moodle, it would download that document as a binary .doc file and download correctly. But Moodle at the time did not know about .docx. So if you had a link to a .docx file on Moodle, you would click on it and it would download as a bunch of gibberish. Because what Moodle was doing, Moodle being hosted on Apache at the time, what Moodle was doing was converting the binary information that is part of the .docx file into ASCII text and then sending the ASCII text over the network, and the web browser would look and see that, oh, I'm receiving text, let's just show off this text on the window. And so the user would look at this and go, what is, I have no idea what this is, this looks like code. The solution at the time was to tell people to right click on that link and choose download file as, but what the solution was to implement a asterisk MIME type extension, meaning a what's that called? Wildcard for, okay, if I don't specify a particular type on how to download an extension, then by default, go ahead and download it as an application octet stream, meaning just download it as binary by default unless I tell you otherwise. And so this is a rather standard configuration nowadays for most modern web servers, so that if it does run into file extensions that it has no idea or it has no other configuration for, it will just send that information as binary content and not text content, just to get past the problems that we had for this particular example. All right, I believe last-ish topic is the idea of how to host multiple websites on one particular server. In general, one way is to host a website to a unique IP address. That one website, one IP address. If you have multiple network cards, you could put a different IP address on each network card and then bind a website to each particular network card. So that if you browse to a particular website, you're going to get a particular, if you browse to a particular IP address, you would get a particular website. And for a long time, this was the best way to host a website. One IP address, one website. The problem is websites kept getting very popular, and in order to host multiple websites, we needed some way of hosting this so you'd have more than one website on one IP address, because we just run out of IP addresses. We have already, but we wanted to be able to host a lot more websites using the same single IP address. For this configuration, though, you could also have a one network card with multiple IP addresses. In the Linux class and the Windows class, we've gone over how to assign multiple static IP addresses to individual network cards. In order for this to work, you must assign the IP addresses to the network cards first in the operating system before assigning the IP address inside of either Apache configuration or in the IIS manager. That IIS manager and the Apache configuration file will let you type in whatever the heck you want. If the operating system of the server is not using that IP address, then it's not going to pay attention to any traffic for that one particular IP address. I mentioned this as a gotcha. One of the labs later on in this chapter or so is going to ask you to add multiple IP addresses. And I'm warning you right now, If you assign an IP address to a website without first assigning that IP address to your operating system, things are not going to work. And I'm going to ask you, hey, why isn't that IP address working? I'm trying to ping it from another location, but I can't ping that IP address. Well, the answer more than likely is you didn't assign that IP address to your operating system. All right, so second way is you can bind an IP address, you can bind a website to unique IP ports. So two websites or more can use the same IP address, and one responds to port 80 as normal for HTTP, and the other you would tell it to respond to a different port number, like port 8080, as in the second example. You could assign maybe a third website to listen to port 8000, 8000, or port 1337, or whatever port you want to configure. As long as that port is not used by any other server process on that server, then the server, IIS or Apache, should hear any requests coming through that particular port and respond with that particular website. The problem with this method, though, is the client needs to know the non-standard port number. And so if you wanted to give a website on port 8080, then you would have to specify in your URL :8080 after that particular server. And it's not very, it doesn't look nice. It looks kind of ugly. And if, but typically as humans, we can remember the domain name, google.com, but we don't often remember the port numbers. Like if we said, hey, in order to use Google, you have to go to google.com :1234. I don't think we'd remember the .1234. We would remember the google.com, but we wouldn't remember the 1234. So most often nowadays, this is used for actually hiding some hidden web servers that some server applications will have some configuration control panel stored at a particular hidden port that isn't supposed to be known by anyone else. And so the specific port number isn't used a lot. It can be used, but it isn't used a lot. It's more used for internal testing or whatnot. That we don't have to specify the port 80 because HTTP is by default uses port 80. But if you're going to use any other port, you have to include the port number as part of the URL. Otherwise, it won't go to that particular website. The last method is to use what are called host header names. If you remember in week 1, when I introduced the whole idea, week 1 or 2, when I introduced the whole idea of HTTP 1.1, that clients typically send 2 lines in their request. The first line is, hey, I'm trying to request this path. And the second line is, I need to request that path from this particular domain name. And this is why that particular 2-line request is sent. That it is possible to, using DNS, bind multiple domain names to one single IP address. And the web client, will go to whatever domain name that it's being sent to, and as part of its request, will send the not just the index that they're looking for, the path that they're looking for, but the domain that they're making that request of. And so the web server can parse that, can look and see, oh, they're requesting a page from cs.clackamas.edu, so I should pull the information for that path from the website that is bound to cs.clackamas.edu. And same thing for www.clackamas.edu. We could have both those domains on the same server, and as long as the client specifies which domain it is requesting content from, the requests will go to the correct server. The requirement for this, though, is that DNS must be correctly configured to go to that same particular IP address. Unfortunately, this part of lab, which I'm probably going to be leaving in, I'll try and cross it out if I remember that. But this part of lab will not work from the home environment. That I don't have control over your DNS servers at home, but were we in the annex, I could specify that all of these domains could go to one particular IP address in your particular groupings, and you could play around with host header names. That since the client specifies which domain they're trying to get to, your web server should automatically refer to the individual content for each one of those individual domain names. In IIS, the multi-site bindings, you go to the particular website that you want to play around with and go to the bindings property. There's one special setting called all unassigned. The all unassigned address, or the setting there, is used when either a single IP address is assigned to the server, or when a server has multiple IP addresses that are not specifically bound to another or a specific website. This is sort of the catch-all. Hey, if there's no website assigned to this address, then use this one by default. You can kind of consider this the default website. There's only one website in IIS that can use the all unassigned setting, and originally it's assigned to the default website that is built in. In Apache, we have to use a container, and the specific container we're going to be using is called the virtual host container. And what you do there is you put your configuration directives inside of the different containers. So here's an example for multiple ports or different ports on one particular server. So I'm going to create a virtual host container. I'm going to bind it to IP address 1.2.3.4. And the document root, or the content for this particular website, is in the home directory in example 1. I messed this one up. The second container should be the virtual host 1.2.3.4, port 8080, and I should have changed this to example 2, that the document root for IP address 1.2.3.4 port 8080 should be a different directory than what would be under port 80. And so I will fix this later on, but for now, know that this should be example 2. But that should show you that different content would appear under different ports depending on when they were accessed. In Apache, the way you would set up host header names is you would need to create a name virtual host directive to give the name of the site. You are required to, not the name of the site, the IP address. You need to give the IP address before any of the virtual host containers are created, so that Apache knows that that particular IP address, when it receives a request, it really does need to double check which domain the web browser is requesting from. And so at that particular point, you can create your multiple virtual hosts on that same IP address, but you need to make sure that the server name directive is included under each different virtual host. So notice server name for virtual host 1.2.3.4 says example1.com, and the directory for content for example1.com is, example1. And same thing for the other virtual host, that even though it has the same IP address, the server name is different, and thus the document root is different. And so that's how you would do it under Apache, to do multiple host header names on the same server on the same IP address. For Apache, instead of the all unassigned directive, we have the default virtual host. And so it's the underscore default. This works the same way that you typically have any unassigned IP addresses, any IP addresses that are not assigned to other websites, would by default go to this particular virtual host, plus its settings for document root, etc. For the name virtual host, you can do the same thing for any unassigned host header names that you might have additional DNS entries that point to your particular IP address, but don't have a particular website specified for them. And so this is how you would set up a default. Hey, if you don't have a particular website for a particular DNS name, well, then use this particular virtual host instead. All right. That concludes this particular presentation on getting started with creating websites. The lab should be available. I should be available during regular lab time. If you have any questions, make sure to send them over Teams or come see me during lab time hours in Zoom. Otherwise, I will catch you in a little bit. Make sure you let me know if you have any questions.